Statistics is a research tool that we use to interpret the world around us. Statistics has many tools that can help us interpret data. Let's talk about one. The significance level, which is also known as alpha, written in an L shape, is the size of the shaded region. If we had a significance level, for example, of 0.05, it's basically telling us that there is a 5% probability of falling within the critical region. A critical region is the value of a test statistic at or beyond which we will reject the null. This is what we want, as the whole point of the experiment is to prove the null wrong.
Hi, today we'll be conducting a one-sample z-test. A one-sample z-test is conducted when we're trying to figure out what the probability is of a score landing within the normal distribution. Follow me. Let's think of it this way. The average stress level for a kid in our population is 50, with a standard deviation of 10. We believe that kids who have lived at 10 or more locations are more stressed on average, so we pull a sample of 16. Our sample size showed us that the average stress level of these kids is 56.
So we're going to do a z-test. Now you might be asking, why the heck are we doing a z-test? We're doing a z-test because we know what sigma is for our population. And for a z-test, we're simply determining the observed statistic, which is 56, minus our expected statistic, which is 50. And our sigma is 10 divided by the square root of our sample. And so all we need to do is plug it in and solve for a test statistic. Z equals 56 minus 50 over 10 divided by the square root of our sample size, which is 16. And after you do the calculation, we find that Z equals 6 over 2.5, and our test statistic equals 2.4. What does that mean? The material we're wrong.
Now that we have our test statistic, we need to determine our critical value. Now we're going to find our confidence interval. To find that, we're going to use our z-table. Now here we're defaulting to a 95% confidence interval, and our z-value at 95% is 1.96. So now that we have our test statistic and our critical value, we're going to plug it in. Here we have our normal distribution, and here we have our critical value that we just found at 1.96. Now what we're trying to determine here is whether or not our test statistic falls in this area called the rejection zone. And if it does, what we do is we reject the null hypothesis. If it doesn't, we fail to reject it. And in this particular case, at 2.4, it falls well within that area. So we must reject the null. So what does this mean? Since we were able to reject the null hypothesis, we can say with 95% confidence that students who move 10 or more times are in fact more stressed than the average student.